Okay, so we're going to try something a little crazy. Here we have some hickory drumsticks. So I took one and I cut 6 inches off of it. Okay. So here we have a 6-inch spindle reload. Okay. As you can see, I started to mate it. And here I have a hickory base. You can see there's no notch. Okay. Just to get that started, we're going to clamp that down. And all right, let's start the clock. So we're trying to get another volcano coal. Again, a volcano coal is when all the coal dust builds up in a ring around the friction on the base. Now, if the yucca took 5 to 6 minutes, I imagine this hickory is going to take quite a bit. Now, the problem with my base here is that it's not very wide. And I think a lot of the coal dust is going to spill over. So let's do this. I'm going to stop for a second. And I'm going to place a huge pile of dust all around, so that the dust doesn't just fall off the side. Okay. So let's get back to that. Start the clock again. Actually, it's snagging some seed heads. So it's brushing away the dust pile, which is exactly what we don't want to have happen, right? Okay, here we go. Start again. So we're getting a good ring already. Let's see if I can keep it warm. You don't really need to see me pumping, but let's get in on that. There we go. Okay. And the trick is really just duration and energy. So the reason, again, for the pump drill is it saves on energy. It's a bilateral force, so I don't have to worry about a unilateral force throwing everything off. So time, energy, keeping everything in balance. We're getting a good volcano going. The dust looks perfect. Perfect color, perfect consistency. Couldn't ask for better dust. It's looking really good. So that's a 6-inch spindle, and there's probably about an inch locked inside where the hose clamp is. So when all is said and done, I'm going to remeasure the entire spindle. kind of blowing on it a little bit just to not only keep the smoke out of my face, but to see if we can't get ignition. By the way, the humidity, it's July. It is now mid-July 2013, and it's over 90 degrees outside with a high humidity. The sky is clear, but this is New Jersey, and it's a very high humidity. And we're dealing with pretty good hardwood. One most people would never want to touch. I'm willing to bet we have a coal, but I'm going to keep going. Because it's not a competition about how fast, but that everything is kept in balance and you get the fire. I'm just hoping my string doesn't break. I'm putting a lot of pressure on this pump drill. And thank God I'm using a pump drill, because I would be exhausted with any other technique right now. That's what I love about the pump drill. It saves so much on energy and allows you to go so long. I seriously think we have a coal, so I'm going to lift this up carefully. Okay. Yes, we do. Alright, let's take this off. Let me fix my screen. Sorry. Okay. That's a nice volcano. That's smoking real good. Oh, look at that. Look at that smoke. There's coals buried in there. All around, I'm sure. We just got to get them to glow. There we go. It's glowing. I am just dripping with sweat. I'm trying not to sweat on it. So here's the thing with the Prenotch, at least with the volcano. If you can just keep going and keep everything in balance, a coal is going to end up somewhere in the outer ring. If everything is in balance, it can be done. Well, I think that's proof enough. That looks pretty darn good. So let's keep moving on, shall we? Let's keep going. So by the way, here's our spindle, and it's gone down to about 5 inches. Okay, and this pencil mark that I've made here, that's how much was inside where the hose clamp was, and that's 1.5 inches, as you can see. About 1.5 inches. All right, so we went down 1 whole inch to get that volcano of hickory on hickory. All right, again, let's keep going. Oh, here's our base. And as you can see, it not only did a sphering, it pointed. as it worked its way in. So, alright, let's keep going. Okay, so we're ready to start our next and last volcano external coal ember. Now, what we're using now is evening primrose. I'm sorry. Evening primrose. So my bag of spindles from way back in the day. Okay, as you can see, I stripped the bark off to prevent that the brushing effect for the because we don't want to destroy our our volcano, our gathering of the coal dust along the outer diameter of the socket. Okay. So our actual diameter here of this evening primrose, which is a hollow, right? It's a hollow, but fairly thick wall hollow. It's 5/8 of an inch. And today we're using lumber pine. So as you can see, we're going to do this notch, not notch, but this socket here, which is a 1/2 inch hole inside a 5/8 inch hole, because this is tapered to get the axis going. So let's clamp this down. Get some light. Should be a little better. Again, we're doing the pump drill. I didn't change the cord, so I'm hoping my cord is not going to break on me. And I'm going to add a little bit more light to our test place here. Hold on one second. It's a very hot, muggy, sticky, humid, mid-July day. It's a nice clear blue sky, but I haven't even started. I'm sweating already. So you don't need to see me really pumping, so let's get a close-up in on the base area of where our volcano is going to form. Okay. Let's back that up just a bit. Alright, so here we go. As you can see, it's not mated. So we're just mating it together, and we're just going to keep going. We're starting to get a little bit of dust in our circumference of the socket. Hopefully we won't encounter any fibers that's going to destroy our volcano. The dust looks perfect. I always want to say that the perfect dust usually looks like coffee powder. You know, there's coffee grains, but obviously you don't want particles that thick. You don't want coffee grains. You always want like coffee powder. That's the consistency you really want. The color, the texture. So here we're doing a plant stalk which is a hollow. It's not a pit, really, but it is a thick, fairly thick wall stalk. Oh, I forgot to measure. I'm sorry, but I forgot to measure the length of our reload and how far we're going to go down. But I guess we'll just let that go for now. But because it is a hollow and the only surface area is the walls, there's less surface area, obviously, than a spindle. I mean, a solid spindle. So in that instance, this is, by the laws of physics, going to burn down much quicker than a solid. Again, I'm blowing on the smoke to not only keep it out of my face, but hopefully if there is a coal somewhere in the ring, it's going to need some air to survive. And thank goodness for the pump drill, because just imagine doing this with a hand drill. Even if it is a team, even if it is, as I mentioned earlier, where you just keep trading off and going with a group. This is an incredible feat in itself, to try to attain something like this. Your need must be great. Imagine the stemming, the sacrifice of our ancestors. So we do this in order to truly understand. Oh, we got a coal. We got a coal, definitely. Okay, so let's take that out. We got a few, actually. Let's widen that out. Sorry. It's like I don't know how to use a camera. I'm trying to keep it in focus. There we go. So here's our plant stalk. I'm sorry that's out of focus. Hold on a minute. There we go. So we got a bunch of coals in there. Look at that. That's a very impressive volcano. Alright. So, sorry that keeps going out of focus. It has to be the lighting. So we're going to be moving on to, we're going to do the next part of the external, coal ember. I apologize, really. The external coal ember. The shallow external ring. Okay. So, I'm sorry that's not our focus. Let's keep going. Alright, so let's continue on our next part of first friction fire theory. Let's see. So we're in the section of what I call the internal variation of the Prenotch. And it's my understanding, of the Prenotch can be traced back to basically one person whom I've already mentioned quite a few times before, and that person is Barry Keegan. Back in the 90s, he taught a lot of classes. They had a school for a while. Him and a friend of ours, Anthony Phryday, and these guys were very innovative for their time back then during the 90s. I mean, if I were to call them anything, I would call them at the time landmarks. If you wanted to know something, if how far maybe something had gone at the time when it comes to primitive technology, when it comes to experimentation, I would have always asked them, because they would always try to take things a little farther than what everybody kind of already knows. So I've already mentioned Barry Keegan a few times during Fire Saw, Fire Thong, other times as well. And again, Anthony Phryday. If you were to look up how to do a pump drill in a completely primitive way, using only stone tools, the only article you're really going to find is Anthony Phryda's. So we have yet to see another article done that way by anybody else. And that was back then, in the 90s. So hats off to these guys, and credit to these guys for helping me be where I am today, right? So during that time, during the 90s, they taught a few courses. One of their participants of their courses was a guy named John Leeds, and he took, well, during one of the fire workshops that I guess they ran, Barry was teaching or showing, he was at least demonstrating the no notch or the notchless technique, and Barry was demonstrating with cattails and mullins. And mind you, they were only doing the internal version, as far as I could tell. They weren't doing the external ring version variation. And John kind of took this and ran with it a little bit, and Barry even pointed that out, that even John had gone a little farther than he had, which is very commendable. John ended up writing an article, and I think it was for the Primitive Technology magazine. But John was working with mullins, burdocks. He did ragweed, and I think an ailanthus. And so he, for a while at least, was just only getting coal embers from this internal technique. He had basically gotten it down very well. And actually that's this article right here with all my notes on it. I had called John Leeds to have a little bit of a talk. He was very helpful, very nice guy, because we had never met, but we've heard of each other. And basically comes out as a 2-page article if it's in Arial font, and very helpful. But again, this is an internal coal hammer that they're describing. So if you want more information on this article, just email me, okay? Because I obviously don't have copyrights to it or permission for it. But John, I'm sure doesn't mind. He put that article out there for the knowledge of general people, so I'm sure he wouldn't mind me letting you know how to get it. So what else? So we're talking about the internal variation, and so the internal variation, as opposed to the external. So we can't get away without a diagram, right? So here's our pre-notch variations. We have 2: external, internal. Now, a quick breakdown of the external is that the spindle is convex, if you can see. The spindle is convex, and the base, the socket, is concave, right? And together they mate, and there is no space There's no space in between, so therefore the dust has to kick out and create these, an external ring. This is a cross section. So this is a pile up of the external ring here and here. Okay? And therefore the coal ember kicks out, goes into the pile, gets air, and ignites somewhere in this pile, 360 degrees. Okay? Because there is no space. But once it leaves, it gets air. Okay? The internal version is a little different. And here I have 3 examples. One is you have a completely hollow space. Okay? And we're going to do an experiment next, which I'm going to show you with bamboo. So just to clarify that one. Here the dust will end up inside this space. Also, this is a thin wall. Let me go back to the external. This is more solid. Excuse me. This is more solid. Either you have thick walls with a very small lumen in between, or you have a fairly solid but low density spindle, such as a cattail or a yucca. Now, if you really look at these materials, the inside is very, very soft, like a pith. Okay, in fact, they could probably even get away as being a pith, but I call them solids because they look solid, they feel solid, but the real difference is that the outside walls and the inside only slightly vary in density. Okay. So back to the internal. Here we have a very thin wall and a lot of space in between, inside. Okay, so here we have a hollow space. Thick wall or solid, thin wall, internal. Okay. All right. So the dust has a place to go. Here it doesn't have a place to go, it goes out. Here it does have a place to go, it can end up inside. Okay? The difference between these two is here in the fire triangle, we have temperature, we have fuel, and we have air on the outside. With the internal, our problem is that we have fuel inside, temperature inside, but no air inside. So you eventually reach a point where in order for it to start combustion, to ignite, there has to be air, right, for the fire triangle. So you have to have the timing, the duration just right in order for that to ignite. You have to lift up, okay? The problem is if you go too long, you're going to end up charring. You're going to have a high temperature without air, and you're going to get char. Okay, we don't want char. The other type is basically a pith, which is a hollow space with a very, very soft inside thin wall. Okay, thin wall of a higher density, inside very, very soft. So what happens is, as you start to burn down, the pith just gives way. In the pith giving way, this creates a space. And again, the fuel goes inside, the temperature is all locked up in there, but there's still no air. So according to your timing and your duration, you have to lift up, let air inside. The key is knowing when that's going to be. Here's a quick variation of what Barry does with a cattail. He will actually dig a small space in the socket. It's kind of hard to see. He'll take a sharp stone and just drill down into the socket a little farther. This creates what I call a reverse space. A reverse space. So when he lifts up on, say, a cattail, this dust that's down here kind of sticks to the bottom of the spindle. It just sticks to it. So when he lifts up, that dust is stuck to the bottom, and then you just start blowing on it, and once it reaches air, okay? I call this the reverse space. Here it's concave, the spindle is convex, all right? And you have to be careful with this because once it mates, it may mate into that space. All right. All right. So my theory is that unlike the external technique, which has no space and can get air once the coal leaves and goes into the ring, the internal variation somehow our ancestors discovered when they worked with different materials, they must have found that the coal ended up inside the space instead of outside. But what was the difference? Timing had to be a difference as well, I think was really important. And understanding that there was a collection space. Okay. But in order for that to work, it needed air. So your timing had to be right before it charged. The obvious or not so obvious problem, which is an imbalance, is that air. The air, if you're going to have any real kind of description between external and internal, is that the external will get air because it leaves, it goes out. Internal, no. So you run the risk of charring. All right. Let's see. So here we have our 22 variables, right? Health is an issue because we have a STEMI issue, a sacrifice, a lot of blistering. Hopefully you have it. Back then, our ancestors probably did teaming, but with low density materials, they probably discovered a few or one person could pull this off. So energy, hopefully they had, like I just said, multiple people. Otherwise, a low density material can change that where you need less energy. One person could probably do it. The need is obvious. You need fire and reason. A lot of critical thinking, problem solving had to be done in order to figure out how to do friction fire pre-notch, because you don't even know that a notch is better. You don't even know that yet. So the need is obvious to stave off death. Okay. Skills, these guys just probably kept going and communicated to each other what looks like is working, what's not working. Resources, I'm not very familiar with materials that would be found in Africa, but I'm sure with all their experimentations, they discovered what sizes, what densities are going to be better than others the more they did it. Chemical, moisture, obvious issues. Density, hardness, obviously the spindle stalks that they chose or created or processed, they figured out that the lower the density, the easier it was. The fuel creation, was the fuel coming externally? Was the fuel internally? The containment or their notch, there is no notch, it's pre-notch. So again, where does the fuel go? It goes in the outer ring? Does it stay inside? Depending on the type and shape of the material. Is it a hollow or pithy? Or is it more solid with a thick wall? It's going to determine structure and function, okay, of what the technique is going to be. Air is really the case where if you can get a coal to kick out and go in an external ring pile, that's going to work. Otherwise, with the internal, your timing has to be just right, and you have to lift up and get it to ignite before it chars. Pressure, obviously you're going to have to match the correct pressure with the material. Temperature, one of the key things that really determines how this is going is the amount of smoke that you're producing. And that's a key thing that Barry said to me a few times. He calls it blue smoke. And I kind of get the idea of what he means, where it's just so productive and dense and thick that I can understand why he calls it blue smoke. So there's a period where that happens, and he says after a few runs of that, it's probably just about ready, but you know, it takes practice to see and understand. Back and forth reciprocation, we're using a bilateral method. In our experiments, science of the basic form, we're doing pump drill, just to stay, keep our health issue in balance. And but now we have to move on to where this is a real practical application, where we have to prove what our ancestors probably did back then. So we're doing hand drill. This was the only method, and the only technique. So axis. Obviously, the straighter the spindle, the better the turning. Rotations. Obviously, the better rotations one had, the more effective it was. Duration time. That's a big deal between the internal and the external. Like I've said, you don't want char if it's internal, and in the external, you just keep going until you see your external pile at least start to smoke if it gets there. Speed, that you have to determine. Obviously you need enough to get that blue smoke to raise the temperature, like Barry said. Surface area, we did our experiments with the pump drill, which were at least 5/8 of an inch. And but obviously I'm not going to be spinning with a hand drill something that's 5/8 of an inch. So whatever it is that we're doing, have to do with either 3/8 or a 1/2 inch, up to like a 10 millimeter size hand drill stalk at the base. Stability, of course, is important. You are working with a really low density spindle, but it can't be so low dense that it breaks on you, right? Or does a takeori. And lastly, our issue of space, which is really what determines the variation of which pre-notch is going to happen. If there's no space, it's external. If there is a space, it should end up being internal. But the timing needs to be correct. Okay? On this bilateral technique. Alright, so the first thing we're going to do is start off with a experiment for the internal, and that's the one I talked about here, the hollow space. And we're going to do that with my favorite material, bamboo. What a surprise, right? So with that, let's get going. Let's keep going, right? Alright, so before we start doing pithy stalks, for the internal coal ember pre-notch, we're going to do a little experiment. So in a way, we're moving away from art of the variation to back to science of the basic form. So when we first started doing pre-notch, we were using the bilateral method of the pump drill. Okay. Now, in this instance, we're going to use a tube of bamboo. Okay. Now, the specifics of this bamboo section is that it is 5/8 of an inch in diameter, and the wall thickness is 1/4 of an inch all the way around. Okay, so that's a pretty good sized lumen in there, all the way around. We're going to use a base of pine. Okay, And you can see there's a 5/8 inch socket pre-drilled in there with a Forstner bit. It's not mated. These are obviously not mated yet. Okay. So the idea of what I'm going to do is, in my theory of the internal coal ember, in regards to the external, okay, the bottom of the spindle is convex in the external, so there's no space when it meets the socket. So if the socket is concave and the spindle is convex, there's going to be no space because the space is full, and therefore the dust has to go out along the sides of the ring. But in the instance of the internal, you may have a flat or concave socket, okay, but there is a convex space or hollow space or a little bit of a space inside. So there can be a collection of fuel going, not leaving, being forced out due to the fact that there is a space and it can be somewhat contained. So here's my theory, our experiment, our scientific method. We're going to keep going like we did with the pump drill in the beginning. We're just going to keep going and keep going, and I'm going to fill up pretty far inside this tube with fuel and dust. Now I gather there's going to be a coal ember inside. So, but what I have to do is quickly before it goes out, because there's no air. Again, the point of the internal is that there is no air, and you have to be careful of charring. So when I'm done, what I'm going to do is I'm just going to put it on the bandsaw. I'm going to cut it open, break it open, get it out of there, get the coal ember that's stuck inside out of there, because it's internal, it has no air. So to help me do that, I got 2 pairs of pliers here, small ones. Crack that open carefully. Hopefully not destroy anything in the process. So I think we're ready to give this a shot. So as you can hear, it's raining outside. So we're ready to give this a shot. I changed the cord. The other one was ready to break. Okay. And we're ready to begin. Again, they're not mated together, so we're going to do that right now. So let's secure this down. Now, since everything is internal, there's probably going to be a little bit of an external ring, but that's not what we're focusing on. Since we can't see inside, I might as well just show you the whole pump drilling that's going on, and we'll just have the rain in the background as inspiration, let's say. Could be doing this outside. Alright, I think we're ready to begin. I think this cord is a little short, but it'll probably stretch. Let's get this mated, warmed up. So we've started the clock. Let's just keep going. So again, the idea is that the internal space, the lumen inside the bamboo, is going to fill with some kind of dust. And hopefully, as soon as it gets air, after we bust it open, it's going to be ignited. We've got a lot of good smoke going on. The bamboo is working its way down. There's some kind of brushing effect going on, but we're not worried about an external ring. So it's starting to slow down because I imagine there's a reverse center. Okay, let's take that out. What I'm going to do is cut this off in the bandsaw. And there's our coal. Inside. Here is our internal coal ember. And that's our science of the basic form for the internal Prenotch. There is a space inside. The dust collects inside, and due to the fire triangle, we have fuel and temperature. The problem with the internal is that it doesn't have air. So at the point where it can get air, it should ignite. Okay? So let's move on. Let's keep going.